We're back for circle time.
Yeah, I got it. That was good.
That was
Oh,
good. Yeah.
yeah.
Although we'll really struggle to make a circle to two of us. It would just be a line.
Need more people then.
Or more cookies, because they're circular. I'll sort it, right?
Oh yeah. Well, the audience, they could. We'll do it later.
Anyway, on the question. We're doing question 4, January 2008. It's quite a lot, and as you might have guessed, it's two circles.
Yep, so let's just read it out. A circle with centre C has equation x squared plus y squared minus 10y plus 20. Characteristic of a circle, they have two squares.
They do, and part A is complete the square of this. And this is what you do at the start of every circle question, just there happens to be no x constant, so it's just a bracket for y.
Yep. So we'll start with that,
Yeah.
obviously. So the x squared stays the same. The y squared, you want a y minus something squared, and then you want a constant at the other end.
Yeah.
So what you do is you do y minus 5, and that's going to be squared.
It is.
We have a video on this about completing the square. There is a neat little formula.
There is. Now this will give you a 25 that you don't really want.
So you minus it. You minus 25, and you've still got plus 20.
You have. So you're going to put both of them at that side.
Yep, minus 25 plus 20 is minus 5. When you take it over to the other side, it will be equals 5, and that will be your constant k. You'll notice there was no other constants on this side of the equation.
And that's how you do part A.
Part B, part 1. This is normally the order of things. It starts with coordinates of C, which is the centre of the circle.
Yes. What you normally do is the opposite of what's in the brackets of each of these. Now as it's on its own, you can imagine it has a 0 in it, in the bracket with it. So the part centre is 0.
And then the opposite to what's in this bracket is just 5, rather than minus 5.
And that's your centre.
As always, that's followed immediately by radius. This time it's in surd form.
It is, and what the radius is the square root of our constant, and that's why I want it in surd form, because root 5 can't be simplified.
Yep. So that will just be your answer. The radius is root 5. So now on to C. These things always follow in that way, centre then radius.
Yeah.
Sometimes they're one question if the radius is a nice easy square root. This is two questions because it's in surd form.
Yeah.
C, a line has equation y equals 2x.
This line is going to do something with our circle.
Yeah. Part 1 of C, show the x coordinates satisfy x squared minus 4x plus 4 equals 0 for any lines, any points of intersection with this line we have an equation for and our original circle.
So when lines intersect, you just simultaneously equate the equations. And to do this, we're going to use, what am I looking for?
Substitution.
That's what I'm looking for,
We
thank you.
can't use equating coefficients here, and you wouldn't anyway.
Because there's not x squared or y squared. So we put our 2x in place for every y squared.
Yeah, because if y equals 2x, if they intersect, this y must equal 2x, but we've got it in a simpler form here.
So you could do it
Just
there.
put it there, you could just have 2x minus 5 squared. That
Or you
works
could-
just as well.
Or you could put it into there.
You could do that. 2x squared minus 10 lots of 2x. Either works because they're the same equation.
Yeah, so what are you going to do?
Up to you, I don't mind. I think
Hang
this
on,
one's
I
probably
think,
easier.
I think that one, yeah. I'll do that one. So we have x squared plus
2x squared, because that's what y equals here, and we want to get rid of y. So
We
we
do.
can find out what x equals, because at the minute
Minus-
we've got two variables.
10 lots of 2x
2x plus 20
plus 20
equals
0.
0.
Now I'm in the way of some of this, but it'll be clear in a second. So we'll have 3x squared. 5x
5x
squared, sorry.
Minus 20x. Oh, it's where we got the 5x squared from. 2x squared, it's all squared, would become 4x squared. When you add that onto the x squared, it becomes 5x squared. 10 times 2 is 20x, and at the end you've still got plus 20 equals 0.
Yeah, but we want it in just 1x squared, so we divide the entire thing by 5.
Because that gets it all back to x squared.
That becomes 4x, and that becomes plus 4. So
Which
we
is what we
have
want.
done that. So now I need to rub some things out, so ta-da.
Yep. So part 2 says, hence show its tangent and its contact point P, find those coordinates. So, to see if it's a tangent, when you've got a circle and a line, they could either be a circle and a line that never intersect.
Yep.
It could
Or
either-
it'll just touch,
tangent.
which is a tangent, or it will go through it and hit 2 points. And there's a way you can tell this using the discriminant.
The discriminant is the square rooted part in the quadratic form, and it's the b
Yes.
squared minus 4ac. That applies to quadratics, and it tells you how many real solutions there are to it before you actually go ahead and work out the solutions.
And we have a quadratic here, and that's what our equation would be for them intersecting.
Yeah, because
So
that's where it's intersected. The two lines.
So you find the discriminant of this, and there's a couple of rules of this, isn't there, Wayne? So
There's
yeah,
indeed.
run through the rules.
So when you do the discriminant, you can find out if it's greater than 0, then that means that the line in the circle, or the line in the equation, whether it be a curve or a cubic, whatever, if it's greater than 0, it intersects twice. If it equals 0, it's a tangent, it intersects just the once. And if it's less than 0, it completely misses it. There's no intersection whatsoever.
And this is when it equals 0, it must touch at one point, so it must be a tangent.
Exactly. Which is what we want, because it says find it's a tangent. We've found it's a tangent. Now we have to know its contact points.
The contact point P, where it touches our thing.
Now this is the same as when you had quadratics and lines in your further equations, chapter 3 I believe, in the book.
Yeah.
You just go ahead and solve the quadratic like you would any other by either factorising or the quadratic formula, and it should only give you one real solution.
It should, so let's try that.
Yep.
Can we factorise it? I think we can.
I think we can. -2 and
Minus 2, which means it must be x equals 2.
Yeah. So if you have x minus 2 and x minus 2, if you expand them out, it will give you x squared minus 4x plus 4.
It would. And the opposite of one of these brackets, as the same, there's only one you can choose, when x must equal 2.
Which is
So
all looking good for us in our tangent theory.
now that's our contact point of the x coordinate. Do we need the y coordinate?
Yes, it wants a contact point P, so it wants a coordinate.
Now we have our x coordinate, we need to get our y coordinate.
You can put that back into this equation, because it's this equation it's dealing with, not the circle one, it's dealing with the intersection.
And that will equal, this will equal y.
Yep, so you've got 2 squared, which is 4,
minus 4 lots of 2,
which is minus 8.
Yeah,
So that'll be minus 4 plus 4 equals 0.
it does.
So there you go, that's your y value is going to be 0.
So that will be our contact point, will be,
Yeah, just put point P is what it wants.
yeah.
They normally label them P or Q or something, and that will be your coordinate point.
Yeah, will we? But we're not done yet because the question is very large.
Yep, so we have a part D just to finish it all off.
So our part D is,
Prove the point Q, which is -1, 4, lies in the circle.
that sounds a little bit terrifying, but it's not that bad, is it, Wayne?
It's not at all. Let's write this out quickly. We've got a circle,
We have a centre point of our circle.
which we know the coordinates, that was part BI.
It was. And we also have a radius, which is the distance between here and there.
Yep, and that's known as well, because that was the part after it.
Yep, and that is root 5. Now, all we need to know is that this point Q is in between that point and anywhere out past this point.
So if Q was here, it doesn't matter if this is to scale, there will be a line from the middle to the Q, because it's just 2 points, it will just be a line, and it will have a length.
As long as that length is less than the radius, it will be inside the circle. That's all you need to prove.
Yeah.
So,
We need our centre point and our radius, then we
Yeah.
need to work out the length of the line.
we do. So, our centre point is 0 and
5,
5, yeah?
that's our centre point, our
Centre
radius
point.
was
Our radius is
5.
root 5, absolutely. So, and our Q is 1, 4. That's all we need.
-1, 4.
Sorry. That will make quite a big difference.
So we need the distance from here to here.
Yeah.
Now, it's going from 0 to -1, so it is backwards a bit,
Yeah.
and it is down 1, so Q's looking like it's going to be about here,
Yeah.
like that.
So, this difference squared,
Yep.
which would just be 1 still,
Yep, so it's just doing a triangle like this,
plus the difference between these two numbers.
which is just 1.
Yeah.
That difference is 1, that difference is 1. 1 plus 1, and both of those are squared,
Yeah.
but that's just 1
That's
anyway.
just 1 as well. That equals
One.
2, and then
Oh,
you
sorry, 2. Sorry.
and then you root that,
To find the hypotenuse.
and that'll be your distance. And this root 2 is less than our root 5, so it must lie inside the circle. Ah, sorry. Yes, careful with inequality signs. That was silly.
So root 2 is less than root 5, therefore it must be inside the circle.
And that's the question.
So we will see you at question
Number
5.
5. Absolutely.